Good afternoon. In this video, I'm going to discuss optical properties of materials. So you can find this on chapter 21 of Callister. This would be the last video for this term. Maraming application yung optical properties, from solar cells to fiber optics, as you will see in our discussion. So let me share you the PowerPoint. Okay, so you can find this material on chapter 21 of Callister, and this is optical properties. Okay, so as you can see, yung isang application niya, kasi we're going to discuss absorptivity, reflectivity, those properties of optical properties of material. So ang isang application niya ay sa solar cells. Of course, engineering students kayo, no? Are you aware of the advances sa solar cells? So, yung mga current advances niya, have you heard of net metering? Ang problema kasi sa solar cell technology, dati, gumagamit siya ng battery, tapos doon ini-store yung energy na nakukuha sa solar cell. ang problema sa battery, up to now, hindi pa ganun ka-reliable yung technology. No? So, nag-work naman. Kaya lang ang problema, madaling masira. Kumbaga, halimbawa, yung solar cell, tumatagal siya ng 20 years. Yung battery, kahit na daw motolite pa yung gamitin mo, swerte mo na pag makadalawang taon yung motolite, kahit na may mga automatic controls pa silang ginagamit, yung hindi siya mawawalan ng more than 50% na load, yung mga ganun, kahit yung chinecheck pa yung ganun, hindi daw umaabot ng 2 taon. Mas reliable pa daw yung mga batteries na galing China, yung NTP, at least yun medyo mas tumatagal. Pero the fact is, hindi talaga nagtatagal yung battery. Tapos, mahal ang battery. Yun yung current limitation. Halimbawa, yung 100 amp hour, 100 AH na battery, yung China, yung NTP, mga 8,000 isa. So, meron ba kayong mga courses sa renewable energy? So, pag sinabing 100 amp hour, gaano ba kaming energy yung may store nun? So, actually, may convention, Ang convention, minumultiply nyo lang, kasi di ba, P is equals to IV. So, minumultiply nyo lang siya nung kanyang voltage, nung kanyang design voltage. So, halimbawa, kasi parang car batteries yan, 12 volts. So, yung 100 AH, ampere hour na battery, times 12. Ibig sabihin, ang may store lang nun is 1.2 kilowatt hour. Di ba? Times 12, 100. Parang 0.1 kasi yun. So, 1.2 kilowatt hour. Okay na rin naman. Pwede na. You can, kasi siyempre sa umaga lamang, actually 5 oras lang meron, 10 a.m. to mga 3 p.m. No? You're going to use an ordinary inverter. Yun lang effective yung light. Hindi ka lang makakagather ng energy from the sun. 5 hours lang. So, ang may store mo lang na energy is around 1 kilowatt hour kung isa lang yung battery mo. Parang yan. Yung 100 watt mo na solar cell, kapartner nun, ay isang 100 amp hour. Kasi hindi mo pwedeng i-drain lahat yung lahat ng laman ng battery, gagamitin mo lamang doon kalahati. No? So, yung 100 amp hour, kung makaka-store siya ng 1 kilowatt hour, 0.5 lang yung pwede mong gamitin doon kasi 50% lang. Kundi, masisira agad yung battery mo. No? Of course. Ganun yung limitation ng ano. Yung importante doon, alam nyo kung paano kinakalculate yung amp hour. So, halimbawa, lithium ion, ang pamumultiply nyo dyan, 3.7 kasi yun lang yung voltage yun. Diba? 3.7 lang. So, yun, nasa battery yung current limitation ng solar. Pero yung sa net metering kasi, hindi siya gumagamit ng battery. Meron ka lang parang inverter, tapos design na yun na yung inverter, nakasaksak lamang siya sa plug, no? Tapos nakakabit siya sa solar cell, nakakabit lang siya sa solar cell. Tapos nakasaksak lang siya sa saksakan ng kuryente. And then, ang mangyayari, pag gumamit kayo ng kuryente, una nyong gagamitin yung electricity galing dun sa solar cell. Tapos yung sobra, yung hindi nagamit, theoretically, dapat ibebenta niya sa Meralco. Ganun yung technology ng net metering. Tapos wala siyang battery na ginagamit. So yun yung bago. Kasi parang hindi ka nagagamit ng battery, yun kasi yung current limitation. 20 years yung 20 years yung lifespan ng solar cell mo. Tapos yun namang inverter, kasi electronics yun. Made in China rin. Iba locally made, mga Filipino made na inverter. Pwede naman siguro tumagal siya ng 5 taon o 10 taon, depende ano. So wala pa rin masyadong wala pa rin masyadong. Tsaka pwede kasing i-repair yun, electronics yun eh. Pag nasira yung IC, pwedeng palitan, ganun siguro ano. So yun yung pinaka-practical ngayon. Ano? At saka siguro yung kahit yung mga malalaking solar plants, yun din yung ginagamit nilang technology. Binebenta nila sa Meralco. Net metering. Walang gumagamit ng battery. May drawback yung battery. So, ganun yung current state ng solar cell, solar energy. Kasi, alam niyo naman, bago naman, binubuhay na naman nila yung nuclear. Pag tinignan mo naman, napaka-impractical talaga yung nuclear because napaka-delikado. Samantalang yung solar, mataas na rin yung capacity nung napuproduce niyang energy. No? Tapos, yun nga, nagawa na nila ng paraan yung batteries. Diretso na kasi net metering na. Okay? So, maganda yung inaharap ng solar cell. I hope, bago kasi sila magbibigay ng mga general statement, tinitingnan din muna nila yun. Kasi maraming advances yung solar lately as compared sa nuclear. Okay? So, why do we need to study optical properties of materials? So, isang application yan sa optical fibers. So, naka-PLDT fiber na ba kayo? So, nung una, yung PLDT namin, hindi pa siya fiber. Okay naman siya nung una. Speed na. Parang nakababa lang naman yung kinukuha kong speed. Parang mga mga 5 lang ata, 5 Mbps, Tapos, nung nagkaroon na ng fiber, yun, nagka-problema na yung PLDT line namin. Kasi parang hindi na siguro nila mini-maintain, kasi siguro naluma na rin yung mga linya. Maya't maya, nawawala na. Tapos, ang ginawa ko, pina-upgrade ko na siya ng fiber. So, nung upgrade siya ng fiber, nag-improve. Malaking improvement. Consistent na siya. Tapos, di ba nung nag-lockdown, nung March, ang ginawa pa ng PLDT, nag-promo siya. Yung 5 namin, naging 25. Dati, sinusukat ko yun 25 yung upload namin, 25 yung download from 5. Kaya, ang laki talagang improvement nung nagkaroon nung naging fiber yung internet namin. So, yan pa rin yun. Yan pa rin yung isang major application ng optical properties of material, yung optical fibers. The performance of optical fiber is increased by introducing a gradual variation of the index of refraction at the outer surface of the fiber. Siyempre, kailangan medyo mababa yung index of refraction or iba yung index of refraction dun sa surface. Ano, para hindi makalabas yung ano, di ba? Yung wavelength, yung energy, no? Yung electromagnetic wave, di ba? Parang ganun yung so this is accomplished by addition of specific impurities in controlled concentration. So, yan yung isang application na yun, di ba? Solar, tapos fibers, optical fibers. Okay? Okay, of course, this is the basic. Ano, ito yung spectrum, no? Tawag natin dito spectrum ng electromagnetic wave. So, syempre, pag mas mataas ang frequency, ano? Pag mas mataas ang frequency, still remember this? Pag mas mataas ang frequency, mas mataas yung energy. Ano? So, ang pinakamatataas yung frequency is yung mga gamma rays. Usually, yung gamma rays galing yan pag merong nuclear explosion. Ano, mga nuclear, yan yung nire-release ng nuclear disintegration. Ano? Halimbawa, yung uranium, nag-split siya, di ba? May marirelease na energy yon, mga gamma rays yun. Kung tandaan niyo pa yung chemistry niya. As you can see, yan, mga 10 to the 8, ano? 10 to the 8 yung kanyang energy level. Ito yung frequency niya, ano? 10 to the 22 Hertz. Tapos sunod sa gamma rays, you have the X-rays. Ginagamit sa pag nabalian kayo, di ba? X-ray kayo. Tapos susunod sa X-rays is your ultraviolet or UV. So, ito yung frequency niya, ito yung wavelength niya, no? UV, ultraviolet. Tapos susunod na dyan yung visible. So, itong visible, kung tandaan niyo pa, lalo yung mga chem-ing, di ba from ano yan? From 400 nanometer to 700 nanometer or 0.4 micrometer to 700 micrometer. Ito yung, di ba, dito pag gumagamit kayo ng spectrophotometer, dito nagre-range yung wavelength, 400 to 700. Tapos, di ba, Roy GB ba red, orange, yellow, GB, blue, violet. So, pinaka-energetic syempre yung violet. Kasi mas mataas yung kanyang frequency o kaya mababa yung kanyang wavelength. So, ito yung pinaka-energetic. Tingnan niyo, ultraviolet, tapos kasunod niya, violet. Blue, di ba sabi nga, yung blue flame daw, yun daw yung mas mainit. Parang ganun yung ibig sabihin ng energetic. Yung red, yun yung less energy. So, 700 nanometer. Okay? So, pagkatapos ng visible wavelength, infrared na. Kasi kasunod na siya ng red infrared. So, ito yung sa laser ata, infrared yan, sa infrared. Yung sa remote, di ba? Yung sa remote, infrared yun. Di ba? Yung mga cellphone nyo, may remote sa infrared yan. So, mas lesser yung energy nun. Tapos, susunod sa infrared, microwave na. So, if you have microwave na pang-init, o kaya yung cellphone nyo, microwave din yung ginagamit nun. So, ang question dyan is, nakaka-damage ba? May harmful effect ba ang microwave? Halimbawa, yung frequency ng mga cellphones. So, generally, ang answer dyan is, ang sabi ng science dyan, wala. Kasi less energetic tong microwaves, no? As compared sa visible. Yung visible nga, hindi tayo na-damage, di ba? Yung nakikita nating light, di ba? Sa visible. So, lalo na yung microwave kasi less energetic siya. Ganun, theoretically yun. Pero syempre, meron naman tayong hindi alam na posibleng mangyari. Pero current state ng science, ang pag tinanong kung dangerous ba yung mga towers ng cellphones. So, ang theoretical answer dyan ay hindi. Kasi less energetic ang microwave. So, pagkatapos ng microwave, you have the radio and television. So, nandito na yung di ba? Yung franchise ng ABS-CBN, nandito na yan. Nandito na yung electromagnetic wave niya. Nasa 1 meter to 1 kilometer. So, depende. Yan yung radio and TV wave. Okay? So, I hope you remember this from your from your general chemistry and from your physics, Okay, so let's go to the basic equations. Sa Chem-Eng mahalaga to every now and then biglang na lang to sumisingit sa board exam namin. So hindi ko na lang alam sa ibang sa ibang engineering discipline, So ito yung mga basic. Halimbawa, what's the relationship between wavelength and speed of light? Probably sa ano lumalabas din to. Ano? Sa ECE. Yung mga ECE ba? So, speed of light, C, is equals to frequency times wavelength. So, ang wavelength, yung, yung lambda, no? Kasi length, lambda. Kaya lambda yung ginagamit. Tapos ito namang mu, yung frequency, no? So, frequency is expressed in terms of hertz. Yung hertz is 1 cycle per second. Okay? So, C is the speed of light. Visual value is 3 times 10 to the 8 meter per second. So, as you can see, pag halimbawa ang wavelength yung is in terms of nanometer, dapat yung nano gagawin yung 10 to the negative 9, no? Para maging compatible siya dito sa meter per second na speed na 3 times 10 to the 8. So, pag ito meter, wavelength meter, tapos ito per second, compatible na yung ano? For nyo? So, halimbawa, ito yung C. Ito, parang constant kasi yung C, di ba? Speed of light is constant. So, 3 times 10 to the 8 meter per second. Tapos, halimbawa, itong wavelength is nanometer. Yung nano, pinalitan yung times 10 to the minus 9 meters na lang yun. Tapos, ito naman, per second. Yung hertz is 1 cycle per second. So, that's how we operate this equation. Ano, C is equals to lambda times V. So, huwag niyo kakalimutan ito. Gawin niyo itong stock knowledge. Okay. So, next equation is the Planck's equation or the Planck's constant equation. E is equals to Planck's constant H times the frequency. No? So, yun lang yun. So, as the frequency of the electromagnetic wave increases, its energy also increases. Yun lang yan. So, ang constant ng proportionality ng frequency at saka ng energy is the Planck's constant. So, napakaliit na value nito. You can retrieve it from the calculator. Ano? So, yung letter H. Siguro nasa physics lang yan. So, just retrieve it using constant. So, mode 1, tapos shift, constant. Electromagnetic, physico-chemical, electromagnetic. Probably number 2. Yun. So you can retrieve the Planck's constant from your calculator, no? Wala sa number 2 ulit. Shift, constant, probably universal. Ayun, universal, number 1 ang Planck's constant, ano? So, ang value niya ay 6.62 times 10 to the negative 34. So I think that is in 6.62 times 10 to the negative 34. That is in joules. Ano? So check nyo na lang yung unit. I think it's in joules. Joules per atom ata. So, o joules per particle. Ano? Okay, check na lang. Okay, so ganun lamang yun. Ano? So actually, relatively maliit lamang yung energy niyan. Yan yung wave energy. Ano? So, sabi nila lahat daw ng matter may wave energy. Kahit malalaki tayo, may wave energy. Kaya lang maliit. Pero kasi pag mga atom, maliliit sila. Significant yan. Ano? Yung energy na yan. Planck's constant. I hope you can still remember this from your general chemistry. Parang reviewin lang naman. Ano? So, H, Planck's constant. That's just retrieve it from your calculator. So, number 1 lang. Ano? Sa universal. Number 1 din siya. Kauna-unahan. So, multiply nyo lang ito ng frequency. Ang frequency naman per second lang yan, di ba? So, parang magiging watts na siya. Ano? Watts per atom. Parang ganyan. Kasi joules per second. Anyway, pakicheck na lang yung unit ng 6.62 times 10 to the negative 34. Google nyo lang. Planck's constant. Okay? So, I hope you get this one. This translate your frequency to energy using the Planck's constant. I is the intensity of light. So, I hope you still remember this. Ano? yung total intensity of light, I sub O, is equal dun sa intensity na transmitted, no? Yung nakalusot dun sa material, absorb, yung inabsorb ng material, and then reflected. Okay? Yung na-reflect, of course. So, IT plus I sub A plus I sub R is equal to the total intensity of light. No? Pag tumama kasi yung light sa isang material, merong matatransmit, merong ma-absorb, at saka merong ma-reflect. Ganun lang naman yung ibig sabihin ng equation mo. No? So, if you're going to define absorptivity as the fraction of light absorbed, parang I sub A divided by I sub O, ito, absorptivity. And then transmissivity as I sub T divided by I sub O. And reflectivity I sub R over I sub O. yung sum ng transmissivity, absorptivity, at saka reflectivity will be equal to 1. So basic equation to ng, ng optical properties. Transmissivity plus absorptivity plus reflectivity is equals to 1. Okay? Basic equation lang para lang tayo nag-review. Okay, tapos definition ng transparent. Of course, yung pag sinabi mo transparent, kita mo yung kabila. Nag-ano yung light, most of the incident of light is transmitted. Ganun yung transparent. Materials that are capable of transmitting light with relatively little absorption and reflection. Okay? So these are transparent. One can see through them. Transparent. No? Okay, pag naman sinabing translucent material are those through which light is transmitted diffusely. So, parang halimbawa, glass, tapos merong laman yung glass, makikita mo pa rin naman yung nasa loob ng glass, pero yung itsura niya, hindi kamukha nung pagdiretso mo siyang tinignan. Nag-iiba ng direction yung light pag translucent. That is, light is scattered within the interior to the degree that objects are not clearly distinguishable when viewed through a specimen of the material. So, nagdi-diffuse yung light pag translucent. And then finally, pag opaque naman, material that are impervious to the transmission of visible light are termed opaque. So, pag hindi transmit yung light, hindi nakakalusot yung light. So that's an opaque material. So pag sinabing opaque, most of the light is reflected, di ba? Kaya pwede ring absorb. Basta walang transmission of light. Zero yung, almost zero, approximately zero yung transmissivity. Okay, so these are the terms that you need to ganyan din i-describe yung properties ng optical properties ng material. Okay? And then we have this equation regarding transmissivity and thickness. No? So IT, remember I is the intensity of light transmitted is equals to the original intensity of light times E raised to negative D times X. X is your thickness. Tapos yung beta is the absorption coefficient. So general unit niya is millimeter to the minus 1. This is characteristic of the particular material. So depende sa material. Iba-iba yung kanyang beta, absorption coefficient. Okay? Siyempre, generally pag makapal yung material, kasi negative So generally pag makapal yung material, mas mababa yung matatransmit niya na light, di ba? Pag mas mataas yung kanyang absorption coefficient, ibig sabihin mas madami siyang ma-absorb, mas konti rin yung matatransmit niya. Ganun din. So let's try to solve example problem 21.1. The fraction of non-reflected light that is transmitted through 200 millimeter thickness of glass is 0.98. Calculate the absorption coefficient of this material. Okay, so yung fraction, lang yan, yung 0.98, IT divided by I sub O lang yan. Tapos yung 200 millimeter, yun yung thickness ng material. Okay, ang pinapaanod lang dito yung beta. So, if you're going to use our equation, ito yung equation natin, no? IT divided by I sub O, e to the negative b sub x. Okay? So, siguro pag mag-shift solve tayo, kunin nyo lang yung ln ng both sides. Siguro mas mabilis siyang, ito yung gamitin natin equation pang shift solve. Ano? So, it's just ln 0.98 is equal to negative beta, tapos x is 200 millimeter. Let's try it that way, ano? Okay. So, when you use your calculator, so let's ln 0.98, tapos alpha equal negative, so ang x natin yung beta, tapos times 200 millimeter, tapos shift solve. I'm getting the 1.01 times 10 to the negative 4. This is in millimeter. Ano? So ito yung kanyang absorption coefficient, 1.01 times 10 to the minus 4. Okay, so hanggang dito na lang, and then okay, so just try to answer the final exam. I'll be posting the final exam soon. And you can check your grade on BBL, ano?